In this video, we'll learn how to calculate expected value, variance, and standard deviation from discrete random variables and their associated probabilities. We'll work a problem first by hand, then using a TI-84 graphing calculator. The expected value, or mean, for a set of discrete random variables is given by the following. The mean, mu, is equal to E of x, the expected value of x, which is given by the formula, the sum of x times P of x. This symbol, uppercase sigma, means the sum of x, our random variables, multiplied by P of x, the associated probability for each random variable. In other words, by multiplying each random variable with its associated probability and taking a sum of all of the products, we can obtain our expected value. Let's look at an example. Let's consider this table. Suppose that during the course of a year, the probability of a particular product needing 0 repairs is 45%, 0.45. The probability of this product needing 1 repair is 0.35, or 35%. The probability that the product needs 2 repairs is 15%. And the probability that the product needs 3, or let's say 3 or more repairs, is 5%. Using this information, let's calculate the expected value. Keep in mind that the number of repairs, x, represents our random variable, and P of x represents the probability associated with each random variable. First, let's make sure that the sum of our probabilities adds up to 1. So if we take the sum of 0.45, 0.35, 0.15, and 0.05, we get 1. Therefore, we know it's a legitimate probability distribution, and we can proceed. We'll be using the formula E of x, the expected value of x, is equal to the sum of x times P of x. In other words, we're going to multiply each x value by its corresponding probability, then add up the results. So we'll start 0 times the corresponding probability, 0.45, equals 0. 1 times the corresponding probability, 0.35, equals 0.35. 2 times the corresponding probability, 0.15, equals 0.3. And 3 times the corresponding probability, 0.05, is equal to 0.15. Now we'll sum the results. 0 plus 0.35 plus 0.3 plus 0.15 equals 0.8. Therefore, the expected value is 0.8. That represents the expected value, or mean, or average number of repairs over the course of a year associated with this product. Now suppose we're asked to find the variance for the information in this table. The variance is given by the formula sigma squared is equal to the variance of x, which equals the sum of x minus the mean squared times P of x. All this means is that we're asked to calculate the sum of each random variable value minus the mean or expected value squared, then multiplied by its corresponding probability. We know that our expected value is 0.8 from the previous step. So here's what we need to do. We take our first random variable, 0, minus our expected value, square it, and multiply it with the associated probability, 0.45. This gives us an outcome of 0.288. We repeat the process for the next random variable, 1. 1 minus 0.8 squared times the corresponding probability, which is 0.35, equals 0.014. We repeat the process with the random variable 2. 2 minus 0.8 squared times 0.15 is equal to 0.216. And finally, 3 minus 0.8 squared times 0.05 is equal to 0.242. Now we sum the results. 0.288 plus 0.014 plus 0.216 plus 0.242 is equal to 0.76. This is our variance. To find the standard deviation, all we need to do is take the square root of the variance. You can do this using most any calculator. The square root of the variance, 0.76, equals 0.87. This is our standard deviation. To find the expected value using a TI-84 graphing calculator, we simply take the following steps. First, press Stat. When you press Stat, this is the screen that should appear. Select option 1 for Edit. When you press Edit, this is the screen that should appear. Next, you'll enter the random variable x into L1. Always use L1 for x. To enter values, simply type in the number, press Enter after each one. This is what your screen should look like now. Next, we'll enter our corresponding probabilities into L2. We always use L2 for our probability values. Well, I should say we always use L2 when we're calculating expected value and standard deviation using this process. That's step 4. Your screen should look like this. Once your data has been entered in L1 and L2, whoops, I forgot to put in my last value there. Okay, so once all of your values have been entered for L1 and L2, you'll press the Stat key. Press your Stat key and arrow right to Calc. Select option 1 for one variable stats. With one variable stats selected, you'll then press second and the 1 key, which inserts L1, comma, which is above the 7 key, and then second 2, which selects L2. Now your screen should look like this. Finally, Press Enter to receive your results. As you can see, we obtained the same results for our expected value and standard deviation as we did when we worked the problem by hand. Your expected value, or mean, will be found here next to the X-bar symbol. Our expected value is 0.8. Our standard deviation will be found here. Sigma x equals 0.87. The variance won't display on your graphing calculator, but if you're asked to find it, you would simply take 0.87 and raise it to the second power. That would give you 0.76, which is your variance. So now you have the basics for calculating expected value, variance, and standard deviation when working with discrete random variables and their associated probabilities.